Okay, so let me start. So last class we started integration, and I showed you all how to integrate. Alia, was it definite or indefinite? What kind of integration did we do last class? Definite or indefinite?
Indefinite.
We did indefinite, right? And basically, I showed you all how to integrate um, most cases, right? Most cases. And what is indefinite integration? Indefinite integration is integration without limits. Alia, if it's indefinite integration, we have to add on to the end.
Plus C.
Right, because we need to cater for any lost constants.
Yeah.
Right. So the next thing we had to move on to was definite integration, and this is used in area and volume. In definite integration, there exists an upper limit and a lower limit bound in the curve. And so this is where you how to use if you want to figure out the area. So all you're gonna do, right, Aliyah, Amy, and Kira, you're gonna integrate the expression. You're gonna integrate it. You're gonna plug B into the integrated expression, and then you're gonna minus it from when you put in A into the expression. So Aliyah, you're gonna integrate like normal, and whatever you get when you integrate, you just put in the upper limit and minusing that from when you put in the lower limit. It's very simple. So I'll give Aliyah a chance to copy this down. So Aliyah, you confused?
No.
No? Okay, cool. Oh, Amy, what you could do in the meantime, you can continue with the past paper questions. Since you know some level of kinematics, you could attempt, well, I'll just send you the past papers. Amy, the plan is when I go home after class, I'm gonna travel home and see if I could print the past papers there. If it's anything, your mom could collect it. I doubt it could be this evening. She might have to collect it either tomorrow.
Okay. Mm-hmm.
Yeah. If not tomorrow, well, hmm, I'm not sure because I'm real busy. But see if I could organize it today.
Okay.
Or Amy, if here what might have to happen, right? So if I do get the book binded, I will have to give you the book unbinded. I'll lower the cost a little bit because typically I bind it. Um, but yeah, yeah. That's like the worst case scenario because I see in here that the place I go by, it closes 2:30 p.m. today. And I don't think I'll reach I don't think I even I'll reach down in time for that. And Sunday they are closed. So that's the worst case scenario.
Okay.
Yeah. All right, so Amy, let me send you the kinematics questions. Yeah, you finished with all the integration or no? I still had some integration questions to do.
I still have integration questions to do, but um Yeah. I remember that stuff.
Was it 2017?
20, yeah, 2017 and stuff.
Right. Continue from there, and I'll send you the kinematic questions.
Okay.
Remember, if fast. If I differentiate, accelerate. No. If I differentiate velocity, what am gonna get?
Mm. Um, displacement.
No.
Wait, no. Oh, acceleration.
Right, because a change in velocity with respect to time, that's acceleration.
Mm-hmm.
You can either increase your velocity. This does not mean acceleration. When you increase in your velocity.
Mm-hmm.
Yeah. If I integrate velocity, what again?
Displacement.
Mm-hmm. If I integrate, I think that's it. I already have much. If I differentiate displacement, what would I get?
Velocity.
Yeah.
Okay.
Cool. Aliyah and Kiera, let me know, guys, when you have everything copied down.
Okay, I almost finished.
No problem. Aliyah, 5x plus 3, that's a line or a curve. What is that? A line or a curve?
A line?
Yeah, that's a line. Nice. All right. Aliyah, yeah,
Yeah, I finished.
finish? Okay.
Yeah.
So let me understand what's going on in this question. By the way, Aliyah, 11 over 2. What is a decimal? What is 11 over 2? What's a decimal?
That's 5.5.
Right. Right. Give me a second. I'm gonna share something and you're gonna blow your mind. So in the meantime, Aliyah, I want you to read the little text in like light that was in light blue that I copied down. So I just go like, so what exactly does this mean? I want you to read that from her.
Read it out loud.
Yeah, read it out loud.
What exactly does this mean? It
Mhm.
tells us the area under the line y is equal to 5x plus 3, bounded by the line x plus 0, x is equal to 0, and x is equal to 1 in the first quadrant.
Yeah, you see what I mean by that. Let me show you. You're gonna be, I don't know, I feel like you might be impressed. I feel like you might be, maybe. I don't know. I wonder if you're seeing this screen.
Yeah.
All right, so I have a graph here. Which line here is the line y is equal to 5x plus 3? First of all, tell me that Which line here is y is equal to 5x plus 3? If you could annotate, whichever way to do from earlier, if you could annotate, I want you to show me where the line y is equal to 5x plus 3 is. I want you to show me where the line x is equal to 0 is. And I want you to show me where the line x is equal to 1 is. That's all way to do for me.
Okay.
Mhm.
This line here, the first line here is x is equal to 0,
Yeah.
and this one is x is equal to 1,
Mm-hmm.
and this line is 5x plus 3.
All right. And I want you to shade the area. So imagine you have, so like imagine, so all of those lines interacting with each other, what area would they enclose? Enclose mean like a block up. Show me the area it would block up.
This area,
Okay. And when we did the calculation, how much units squared do we find?
11 over 2, 5.5.
I want you to actually count the blocks in real life now. Count it.
1, 2, 3, 4, 5.
Is 5.5. Is actually 5.5.
Okay.
But you can see for yourself is that like actually is actually 5.5. Watch.
Yeah.
Because this is one, this is two, this is three, right? These two are not fully they're not fully whole ones. So
Yeah. Yeah.
this one over here, we go take out a little piece from over here to make it 4. This is 5, and well, this is the half. So 5.5. You think that
Okay.
cool?
Yeah.
So like without even seeing the graph, we was able to find the area under the graph. That's what integration does do. So
Okay.
earlier, anytime you have a line or a curve, so the line or the curve is typically be like that or like that. We typically enclose it in like in an upper and a lower limit, and both of them must be x. So like x is equal to 5, x is equal to 2, x is equal to -1. Could be anything. Imagine we had a curve like that, right? Then if I wanted, I could have find the area from here, right? Let me just say that this is 0.45 and this is 1, and the equation of the line is y is equal to x squared plus 3x plus 2. No, I'll be minus x squared. How about I find the area? How would I find the area here? See if you can figure that out.
Here, integrate
Integrate what?
y.
I integrate y, and what's the upper and lower limit? What is the upper limit?
Uh, the
So in this
2
case,
and
what was the upper limit?
1 and 0.
Okay, one, no, one was the upper limit. The
Oh,
0 was
1
the
is the
lower limit.
yes. Okay.
So what's the upper limit here?
1,
1 on the lower limit is
0.
0. Look at this example. Where what lines are bounding the curve? I want you to look at this example. What lines are bounding the curve? Meaning like blocking off the curve.
0.45 and 1.
Right, so 1 is the upper limit and 0.45 is the lower limit.
Yeah.
Yeah. So it would look like the integral of 1, 0.45 minus x squared plus 3x plus 2 dx. That's what it would look like. So yeah. Matter of fact, let me get a question like that for you on now. Yes, Olia, if you want to get, actually, not if you want, you have to. Because this could make it, you need the diagram for it to make sense. Right? So this is y is equal to 5x plus 3, right? This over here, this is x is equal to 1. And this over here is x is equal to 0. So I want to little copy down that diagram real quick. Right, so I'll have the diagram copy down. Aliyah and Kira. And Amy, well, Amy, if you want, you can copy down the diagram as well. Aliyah, I have it copied down.
I just drawing the lines.
Okay, no problem.
I finished.
All right, cool. Let me get a question for you all now. Amy, you will have to do a couple of questions in class today. Some very difficult questions. Questions like you never see before. All right. So I'm getting questions. Again, questions, right? One second. Right. So I saw a question there. Let me get it up on the screen. All right, so I have a question here. I'd like you all to try this. So Aliyah, this is a perfect example. Um, so you can see for yourself where you get where you blank out because I bring in some stuff here. Like this question. This question isn't completely just integration. It also tests like previous parts in hard maths. So see if you could do it without looking back.
Okay.
You could look back. You could look back for this, but ideally do that. The concept is simple. All you're gonna do is you're gonna integrate like normal, then you plug in the upper, and you're minusing it from the lower, and you get your answer. So let me say that one more time. Actually, you explain it, someone. How do I find the area? Someone.
You integrate
Mhm.
first, and then you plug in the upper limit and minus it from the lower limit.
Okay, cool. So try this question. Amy, I'd like you to try this question as well. Amy, can you for this question?
Yeah, I
Oh,
just finished eating.
all right, nice. It was simple.
Yeah. Mhm.
Alia, did you get through the first part?
I think so.
Okay, explain to me what we're going on in the first part. First of all, actually, I'm not say anything at all. I want to hear what you're gonna do.
Well, they give you the equation y is equal to x plus 1 into,
Into.
well, in brackets,
Mhm.
x minus 5 in brackets.
Okay.
Um, so from the equation, I use the x plus 1 and the x minus 5.
Explain me, matter.
I put the x plus 1 equal to 0,
Okay.
and I find for x
Okay, but why you do that though? Let me understand what's going on. That's correct, but why you do that? What we have over here?
because this curve crosses the x-axis at the points A and B.
Mm-hmm. So what kind of graph is this? Is that line, a curve?
A curve,
All right. So a curve. Normally, when you had to find the zero crossings or like the roots, what is that to do with the equation?
you put it equal to 0, like,
Yeah, you have to factorize it first too. Remember, like if you have a quadratic equation, like if you have something like if you have x squared plus 10x plus 9, you'd have to factorize that, put it equal to 0, then solve.
yeah, yeah.
But in this question, did we have to factorize?
No.
No. All right. So cool. I trust I get that correct. Move on to part B. Okay, how things going on? How things going with question B? Tell me here, guys, how
Um,
things going with question B?
I think okay.
Okay, all right. All right, guys. Anybody got through with flat feet?
I'm working on it.
All right. Amy, did you get through?
Yeah, I almost finished. Yeah.
Tiara, Kirsten. I'm sure if Kirsten in class. No. Kiara.
Hi, I work. I'm trying to figure out it. I'm trying to work on the last part.
Okay. All right. Okay. Amy, I'm gonna check you looking, right? All right, so that's correct. All looking correct, right? One thing, Amy, you wouldn't say, even though you get a negative answer, it's not actually negative. It's not actually negative. The reason why it's showing as negative is because it's in this quadrant, but it's not actually negative area. It can't be negative. So
Oh,
you
I
just
guess I was wondering if I get a negative area. I was like,
yeah, the reason again that is because it's in this quadrant, like the negative quadrant.
oh, okay.
Just be 36 units squared. So, Amy, you'll see, I'll show you a trick, right? I'll show you a trick to get the positive answer. Right? But if I get negative answers, don't worry. I'm more interested in the magnitude of the fine. So, Amy, you're good. Aliyah and Kira, how things going?
I can answer it, you know.
Okay. Amy, if you want to cry, send me a question. See if you get out. See if you can figure out that one. Okay, Aliyah, so you wouldn't get 1 mark. You might probably get a half mark if they give it half mark. They said write down the x coordinates. The coordinates. If it's coordinates, it wouldn't just be x values. It has to be coordinates. So how would we write the coordinates? Aliyah, tell me how we would write the coordinates.
Um,
And you need to figure out which
minus
one is A and which one is B. So see if you can figure it out.
A could be -1.
Okay, so we know that it is a root. If it's a root, then we know what x would be. What would y be?
What was that?
That was that was Bryce just now
Yeah,
making a weird noise.
yeah.
Yeah, so Aliyah, I saying we talking about the x-intercepts, the roots, the zero crossing, right?
So
What would the y value be?
0.
Right. That is how it is would. That and just said it was equal to zero, and just said x plus one is equal to zero.
Oh, okay.
When
So
you put it equal to zero, that is y. So you see you are saying y is equal to zero. Mm-hmm.
so A could be -1, 0,
Minus one comma zero, and b would be
0. B could be 5, 0.
yeah. So put that on. It would not get your full mark.
Okay.
Amy, what do you think of the question I sent?
I have an idea. Okay, wait, I can tell you my idea.
Tell me. Shoot.
Okay, so first, well, you would have used simultaneous equations.
For sure.
Um, right, and you remember you get two x values and two y values.
Correct.
I would have used the two x values that I get from that and then use that as the limits,
Yeah.
right?
Yeah.
Right. Okay. Just
And
sure.
when you do that, let me just so that's what you're gonna do, right?
Mm-hmm.
And I want to find this.
Mm-hmm.
So I think I'll give you enough hints. What do you think I'll do next? Oh, and this is the so you want to figure out this shaded area.
Yeah. And well, when you use simultaneous equations, you will get two x values and two y values. You just use the x values you get and plug it into the limits and then integrate.
Not so simple. Now,
Oh,
if I do that, okay, look at something. Look at something. Pay close attention to this. When you integrate, normally you're finding an area between the line or the curve and the x-axis. In this
okay.
situation, it's not going to the x-axis. It's like it's here. So what you would need to do is you need to figure out the total area. Now, the total area would be the area enclosed by this or the curve.
Yeah. So I just integrated between um wait where the curve puts in the x-axis and subtracted from the area I get from the bottom there.
Right. Yeah, that's it. Because if you want to figure out this sliver, you need to figure out the whole thing, which is the area under the,
Um, curve,
right? And subtract it from the area under the,
the polyline.
yeah.
Also, Kiara said the Wi-Fi cut off. And she tried, well, it come back and she reconnected right now. Yeah.
All
So
right.
she will join back.
Okay.
Meeting. Yeah.
So, Kira, Aliyah, tell me the final coordinates for A and B.
A is equal to -1, 0.
Mm-hmm.
B is 5, 0.
Right. So that's the answer for A. And the answer for B is correct. I just had to show you something. Awesome. So the answer for A, right, so for A, Aliyah, just explain it to me quickly. So we have a curve. Um, that's a quadratic equation. All curves are quadratic equations. Now it gave us y is equal to x plus 1. They said that y was equal to x plus 1 by x minus 5. And they want us to figure out a and b. What do we call a and b? A and b are the what?
The intercepts,
What intercepts?
the x-intercepts.
Right, because we cut on the x-axis.
Yeah.
We also call it the what? Like when we do in quadratics and then we call it the what? When we cut the x-axis. We don't typically call it the x-intercept. We call it the starts with r.
I don't know.
You had to know this. Think of a tree. What tree have?
Oh, the roots.
Yes, roots. Can't forget that. So we also call it the roots. Right. And at the x-intercept, what is the y value?
0.
So that is why you just no, I feel like you know how to find the answer, but you don't really know why you do what you're doing. You understand now? At the x-intercept, the y value is 0. So that is why you're gonna say 0 is equal to x plus 1 by x minus 5. That's why it is do that. And then you're gonna say x plus 1 is equal to 0, x minus 5 is equal to 0. So x is equal to minus 1, x is equal to 5. And now, if you want to figure out point A, well, we gotta be smart about this, right? If we get a negative answer, obviously that'll be A, right?
Yeah.
Yeah, so, and we know that the y value is 0, so the coordinate would just be minus 1 comma 0, and what would be? It'd be 5 comma 0. That's it there. That's it for E. Let's move on to B now. Right, so that's the answer. B. Use integration to find the area of R. So I'm gonna put in A and B now. I know that A is minus 1, B is 5. So what we currently have is this. So Aliyah, I want you to look at the graph. Say I have the line x is equal to minus 1, and I have the line x is equal to 5. Right? That is interacting with the x-axis and the curve. I feel like you might be a little confused, right? But I want you to pay close attention to what's going on. We want to figure out the area under the curve. And the area under the curve spans over what interval? What interval? Like from where to where?
From -1 to 5.
Right, that's why we need to integrate from 5 or minus 1 to 5. Now, all you notice that the area, it dips under the curve, right? Well, let's see in that. Like this is positive and this is negative. When all of us did it, like should I get negative? I should I get negative, right?
Yeah.
Negative. Well, is there such thing as negative area?
No.
No. So I'll show you all how to combat that. So Amy, I want you to check this out. I'm gonna write a little tip here. Anytime a curve dips into right, anytime a curve dips below the x-axis, you get so this is what we're gonna do, right? So anytime the area dips below the x-axis, this is what you're gonna do. So when you find any area, so you're gonna find the area like normal, you're gonna have b, a, you have f of x, dx. But one change you're gonna make is you're gonna put a negative sign on the outside. So whatever you get, so when you work it out, you're gonna get a negative answer. And if you have a negative answer on the outside, the negative by the negative will give you a positive answer. So that's the only difference, right? So when I want to find the area, check it out, guys. So when I want to find the area here, look at what I'm gonna do. I'm gonna say negative, and I want to figure out the area between minus 1 and 5. So I'm gonna say 5 minus 1, and the curve is x plus 1 by x minus 5. And we are integrating with respect to what? Tell me, Leah, we integrating with respect to what? What is the variable? Aliyah, what's the variable here? We are integrating with respect to
X.
x. So say dx. When we were doing integration, we spoke about this. If you have integral as a product, before you could do anything, you need to simplify it. So that's exactly what we have to do. We have to simplify it, right? But Amy, you catch what we're doing, right? Anytime the area dips below the x-axis, you employ this formula. It's the same formula, it's just one negative sign on the outside. Understand?
Yeah.
All right. So let me do this quickly. Minus. All right, so let me expand this quick. So Leah, in your head, expand that from you'll get x squared.
You get x squared minus 5x plus x minus 5.
Right,
Well,
minus
yeah,
5x
it's
plus
just
x is minus 4x,
minus 4x, yeah.
right? Right. Niceness. Okay. Let's continue. I could now remove the integral sign because I could begin to integrate. We're in a stage where we could integrate. So x squared is going to turn to x cubed over 3 because you add 1 to the power and then you proceed to divide by that new power, right? Add 1 to x to the power 1 is x to the power 2. You divide by 2, right? You add an x term to the constant. Bam. That's it. And we integrating from 5 to minus 1. Right. Right, so I'm going to say 5 cubed all over 3 minus 4, like 5 squared all over 2. Now, somebody is saying that we could have simplified this. We could simplify it if you want. That's fully optional. That's optional, right? So if you want, you could have just say 2, but it's unnecessary. Minus 5 by 5. So we have that minus 1 cube all over 3 minus 4 minus 1 squared all over 2 minus 5 minus 1. Right. And you'll get negative 36 when all is said and done. So that's why we have the negative sign on the outside waiting. So negative by negative 36 is 36. So the answer is 36 units squared. Right. So I trust that everybody is okay with that question. Um, if you want some time to check it out, that's it working, right? To make the changes you gotta make. The only change that you gotta make is just putting the negative sign on the outside. And we only do this when the area dip below the x-axis. Alia, you good?
Yeah.
All right. Um, Amy, getting through that hard question?
Yeah, on the simultaneous equations, it kind of took me long to find the coordinates because I had to use the quadratic equation, no
Yes.
formula.
Sure.
Yeah,
Hmm.
yeah. points I get was decimals, and I check it back on my calculator to make sure, you know.
That's kind of weird. Weird. Weird.
Yeah. Mhm.
Nah, I don't think you're supposed to get I don't think you're supposed to get you're supposed to be able to factorize it. It's supposed to be factorizable. Check back we're working. By chance, did you get x squared minus 11x plus 18? Amy, did you get
Mhm.
x squared minus 11x plus 18?
No.
Nah, this is supposed to get. All right, so I'm gonna do one more case with area, and this is the hardest case. Right, so this topic is find an area between two graphs. Right, so that's the topic. Finding area between two graphs. So I want to copy that down, and I'll explain how we're gonna do it. So let's say we have this question. Right. So Alia, it look like we have a what and a what.
A curve and a straight line.
Right. Which one is Bryce? The curve or the straight line? You can't lie, that was pretty clever. That was very smart. Plan that.
You're lucky
Sometimes
he didn't
I am
hear you.
scared. Sometimes I am scared of my own genius.
You're lucky he didn't hear
So I hate. I find like he would have been impressed. He would have been impressed. Like
you.
I sure he would not see this coming.
No, look, he come.
Bryce, you there? Bryce,
He
you hear
asked
me?
if you
Yeah,
What's he plan?
idea was the plan.
I good, I good. So I have two graphs here. One is a what and one is a what. What kind of graph
Our
is this? What kind of graph is this?
um
what I looking like.
ah
No.
well
So I would see.
actually what I forget you think now you kinda you know
It looking what? Like,
bend
okay, where's another word for bend?
curve.
Curve. This is a curve, but we could use bend for this example. Bend is a good example to use. And this is a what?
Huh?
And what is this?
Um a line.
A line.
Straight.
Line.
Who like pink?
Me.
Ben.
We're trying to see it.
I
Trying to see it. Oh
trying to
nah
say
you
it
wicked.
straight. I trying to
You
say it
wicked.
straight.
Nah, I fully 180 degrees.
Ah, but that was a good one. That was a good one. That was a good one. Anyways,
Yeah,
right?
you wicked.
Um, So this curve here is all jokes. I don't mean it. I don't mean it. So we have y is equal to 5x squared. No, y is equal to 5x minus x squared. And we have y is equal to x. Right? And both of them starting from the what? Well, they're not starting, but we're in for the sake of this explanation, we're gonna reference it to x is equal to 0, which is the origin. Just keep that in mind. Just keep that in mind. So right, I'm trying to say that this is x is equal to 0, right? Is our reference. Right? And this over here, this point. Aliyah, anytime you have two graphs intersecting, where it is used to figure out the point of intersection. Aliyah, please tell me you know this. Please. I didn't know this.
What was the question? Sorry.
Wasn't paying attention.
No, Bryce was in the room.
All right. So, here's my question again.
Mm-hmm.
Anytime you have two graphs intersecting and you need to figure out the point of intersection, what do you use? Aliyah, you're disappointed. You had to know this one.
You could use
I'll give you a hint. You have y and x. Anytime, so how much unknowns you have? You have y and x. And you have to find for y and x. So how much unknowns you have?
one.
Anytime you have two unknowns, you have to do.
Wait, I know it. Hold on.
I know
I
it.
know it.
I know it.
Um, um,
Uh, hmm.
you could integrate.
Yeah, if you want to get a one and add maths or even a two cell, you have to step up your game. The answer is simultaneous equations. Anytime we have two unknowns, simultaneous equations. Anytime you have two graphs intersecting, simultaneous equations. You, you need to know that. So I hope you remember now. Anytime you have two graphs intersecting, a line, a curve, anything, simultaneous equation. Anytime you have two unknowns, simultaneous equations. That's the mantra. Simultaneous equations. But once it involves two things, simultaneous equations. Because you have to solve it simultaneously. Simultaneously usually means two things. Right. So Aliyah, why do you think we get E4, 4? And 4, 4 is the point of intersection. Why do you think we get 4, 4?
You use you find for them simultaneously.
Yes, so I solve them simultaneously. So let's do that. So typically, and I should probably put on what we need to find here. Aliyah, don't dig no horrors. I just saying, I look at you with high standards and I see good things for you. But when you have trouble remembering these things, I get a little disappointed because for me, I see it as a little wasted potential. And I think you're real smart. I think you can do good things. I don't want to see it just wasted. So like, you had to step up, you know what I mean?
Yeah.
Yeah. So in the question, it wasn't there, but I want to find this area. This is what I want to find. Right? I want to find this area. Aliyah, are we accustomed finding this area? Like in all the examples before. Did we find an area like this?
Yeah.
Nah.
Wait.
In all of the areas we found previously, those areas were like
No.
to the x-axis.
Oh, yeah. No, this one is
This one
behind.
kind of stopping abruptly. This one are going down to the x-axis.
Okay.
Wait. Probably use a different color. I miss this color. Nah. Right. So Aliyah, in this question, how much graphs do we have? In all the previous examples, how much graphs we had? Look at the examples. How much graphs we had?
2.
No, we had a one. I know you're thinking that I don't want you to think of x is equal to minus one, x is equal to 0 as lines. They are boundaries. They are intervals. What I'm talking about is this. So in this question, you had one curve. In this question, you had one line, and it was simple. You just had to find the area bounded by that and the x-axis. This and the x-axis.
Mm-hmm.
But now, how much graphs you have?
You have 2.
We have a what and a what?
A curve and a straight line.
Right. And we don't want to figure out the full area. We know how to do that. And we know how to do that.
Yeah.
If I wanted to figure out the full area, I just need this interval here, and I integrate 5x minus x squared. But I don't want to do that. I want to figure out this. So how are we going to do that? Well, the very first thing you have to do when working with a question like this is you need to solve simultaneously. So the first step in questions like this is you're solving simultaneously. So let me do that. Oh yeah, remember how to solve simultaneous equations?
Yeah, you could use substitution or elimination.
Well, you can use elimination for elimination to work. You need the same kind of format. In other words,
Okay.
you need a linear, or a
Yeah.
quadratic and a quadratic. If it's like a mix of both, you can do it.
So you could use substitution.
Yeah, we had to use substitution. So we have y is equal to 5x minus x squared, and we have y is equal to x. So we have our equation 1 and our equation 2. Do we have to make our equation 3?
Yeah.
Yes? Well, explain yourself. Why you want to make our equation 3? You have to tell me why you want to make our equation 3.
You don't need it. You don't need it.
No, we don't need it. You just make our equation 3 to find for either y, like find for something in terms of y or something, and then substitute. But can we make a substitution right from the get-go?
Yeah.
What's the substitution we can make?
X is equal to 4.
X is
Oh,
equal.
no, Y.
We're trying to find this. We're trying to find this. We're trying to find 4.
X is equal to 0.
No. We do substitution with the graphs. So we have y is equal to 5x minus x squared, and we have y is equal to x. So we know
So
we know what okay, so y is equal to 5x minus x squared, and y is also equal to x. So what I could replace y with in either scenario,
x
or I could replace y with x. So tell me what to write.
um substitute y for x in equation 1.
Yeah, that's correct. Some more to write.
X is equal to 5x minus x squared.
How much unknowns we have there now?
True. Well, 2.
One. All of them is
Oh,
x.
well, x. Yeah.
Yeah. Probably gonna solve for that now. Oh, Amy, if you get through with the question, something.
Oh yeah, I see what I was doing wrong. I made a bit of a stupid error, but yeah.
With the quadratic.
Yeah.
Oh,
But don't worry, I get you like almost done.
okay, good. All right. So yeah, tell me what to do next, Aliyah.
You find you make x the subject, and well, you find for x.
Not
So you
quite.
could
But let me hear what you're gonna do. I want to hear what you want to do. Maybe you might be right.
hetero.
So let me. I want you to do what you're gonna do, and we will see if it makes sense. Maybe you're saying it. Maybe you know what to do. But you're saying it the wrong way.
Um, I was going to
Tell me.
put all the x on one side and leave the x squared by itself.
No, no. I need you specifically to figure this out by yourself. Need you. X is equal to 5x minus x squared. What are looking like? Yeah, what are looking like? No way to look up anything. But what is that? That's a what?
A
Right. Is that quadratic? And how do you typically solve quadratics?
you factorize.
Yeah, we factorize them.
Yeah.
Mm-hmm.
And you could carry across the x, or you're leaving it right there.
You can carry across the x on the right hand side, or you could bring across everything on the left hand side. It's up to you.
Well, you could carry across the x on the right hand side, so it will be
If I move across
I
everything from this side, like I have on the left hand side.
0.
Yeah. Right. So 0 is equal to
For, well, x squared.
positive
Or
x squared.
yeah.
How do you get positive x squared?
No, minus x squared.
Mm-hmm.
plus 5x minus x. So it'll just be 4x
We end up with 0 is equal to minus x squared.
plus 4x.
All right, where's your next step? You yourself told me when we're dealing with quadratics, what we do.
Factorize.
Okay, so where's your next step?
Um, you pull out what is common.
Mhm.
So x is common, so it will be x into minus 1 plus 4.
Nah,
No, x into minus x plus 4.
right? So what are the answers? X is equal to what and x is equal to what? Well, the first answer really is x is equal to what?
Minus, well, 1.
X is equal to 0. Watch, this is just x. X is equal
Oh,
to 0.
okay, yeah,
And this one is minus x.
plus 4.
Right? So minus x would be equal to,
Minus 4, so x could be equal to 4.
right? So remind me, what are our coordinates? Remember, what we did here was we put it equal to 0. So we find only what? What we find?
The x
The x what?
coordinate
X, the x-intercept,
intercepts.
right? So
So
now 0.
0, comma 0, and 4, comma 0.
Oh, wait. No. We're rushing the game a little bit. My bad. So we find for x. I forget what question I was doing, right? So we find for x. So this is not a standalone question. So Aliyah, remember when you find for x, since the question is a simultaneous equation question, you need to put it back into something to find the y value. So I have x.
So you
Um,
can find for y now.
yeah, I have an equation I could use to find for y. I could use both really. But which one is the simpler one?
Equation 2.
Yeah, it literally says that y is equal to x.
Yeah,
If y is equal to x,
y is equal to 4.
right? For this one, that'll be 0, 0, because y would be equal to 0. So
Mm-hmm.
when x is equal to 0, y is equal to 0. So that'll be 0, 0, right? And when x is equal to 4, y is equal to 4. So that'll be 4, comma 4. Yeah. And we get 0, 0, and the 4, 4, right? In case you're not seeing the 0, 0, the 0, 0 is the origin, and 4
Yeah.
is over here. All right. So that was that. That's the parts. So anytime you have a question involving two graphs, you need to find the points of intersection, right? And that will tell you the limits. So in other words, we need to integrate from this interval to this interval. That's what we need to do. And let me explain why. So let's move on to the next thing. Aliyah, how much graphs you have?
2.
So how much areas we could find for?
You can find for 2.
Okay. So I want you to tell me something. Just
Wait.
unless you want to see if you can figure it out before I show you.
n-
So
No.
we have this graph here. Um, we know what we're trying to find. We know what we're trying to find. We are trying to find for this area over here. And we have two graphs, so which means we could find two areas. So what could I do to figure out for this region over here? Let me understand what's going on. So earlier we said that we're gonna integrate about these intervals, x is 0 and x is equal to 4. X is 0 and x is equal to 4. We got those because those were the points of,
Intersection.
right? We got those x values from the point of intersection, right? Cool. So the first step was to solve simultaneously and find the points of intersection. And from that, we got the x values. It would not.
Yeah.
What we need to find? We need to find the
Area.
shaded area.
Shaded
Okay.
area. Yeah. So
Now, if you wanted, you could have find, I'm going to split up this graph into two parts. So it can make sense. So yeah, pay close attention. If I wanted, I could consider the graph without the line. I could consider the graph without the curve, right? So Aliyah, based on what I have so far, I want you to tell me something. If I were to integrate 5x minus x squared between 0 and 4, what would I get? Would I get this area over here? Is that correct?
yeah. No,
Why is that wrong?
because it have the point of intersection.
What do you mean?
So
We need the point of intersection. So like the point of intersection defines where we're going to take the limit. So we take any limit from 0 and 4.
to 4. Yeah.
So will that find the total area under the curve? Or will it find like a portion of it?
No, find the whole thing.
No. If I want to find the whole thing, I would need to go from here to here.
Oh, okay.
I not going from there to there. I go in from here to here.
Yeah.
So I will not be finding the whole area. I'll be finding
No,
over
piece
here.
of it. Yeah, yeah,
So you understand I could find that.
yeah.
Keep that in mind. You see where I'm going with this. All right. Okay, Aliyah, let's move on to this. If I find the area under this, what that will look like? Would it be the entire area? So would it be the whole area under?
It'll be the area under.
Would it be the whole thing? Like
No,
in this one, it wasn't the whole thing, and we see that because it had like this sliver we wasn't finding for. But like, how about over here? Is it finding for the whole thing?
no.
No. Why is it no?
Oh no, that could be the whole thing because
Yeah, that would be the whole thing because
yeah, yeah, yeah.
yeah, it just is. Right. Okay. To understand what's going on, right? You understand that them is the areas we could find for. Let me try to overlap it and see what happens. Oh, see what happening?
Yeah,
Okay. So if I find the area for this, and I find the area for this, and I want to find the area that is not shaded, what do you think I ought to do? So look at that. When I overlap it, right? Notice that a piece like this graph, it's kind of overlapping with the shading in this graph. Look at that. See it?
yeah.
Okay, so to figure so And you see like an area that unshaded, like it's not interacting, like it just. Let me make sure what's saying is clear. Can you annotate the area where you see in an intersection? I want you to
If you could,
I want you to annotate an area where you're seeing that the two graphs, the areas interacting with each other.
over here, like there,
Okay, so if I find what that means is if I find the area for this and I find the
it'll,
area for this,
it'll be the same.
what if no, it wouldn't be the same because it's not the same size. Can't be the same.
Well,
But what I'm saying is if we overlap them, this area here, it will take away from this area here. And it will leave you with what? What would it leave you with? So if this area over here was taken away from the curve, where's the area that would be unaffected? Shade up and annotate down the screen.
the top part,
Yeah. So the bottom part, we see that overlaps with the area of the line under the line. So that would get removed. So the only thing we have remaining is the top, right?
mhm.
Which is what we wanted to find for. To making sense. Watch, because this is what we wanted to find for.
Yeah,
What I'm trying to say is if you want to figure out for this, you're gonna find the area for this big thing. You're gonna find the area for this, and we're gonna do those two areas.
uh,
Add them. Why is it add? Think logically. You want to figure out this remaining bit. If you want to figure
oh, you could minus it.
right, because I'm gonna overlap it again.
Yeah,
You want to figure out the top area. So you would
it'll be
need to
the same.
subtract this area from the top part
Yeah,
to get it.
fine.
Mhm.
Yeah,
So, uh, so we're gonna do right. So we need to figure out the area of this. And how would I find the area of this?
you
Telma,
could integrate.
I would
So
integrate
5x minus x squared,
between what limits,
0 and 4. So the upper limit could be 4 and the lower limit could be 0.
right? And I would need to find the area for this one. Mm-hmm. So how would I find the area on the that curve?
Um, it could be 5x. Wait, what was the question?
So we find the area for this. I find the area for this one now.
Oh, um, hmm.
It's very simple. What's the graph? What is the graph?
Y is equal to x?
Right. So what am I gonna put here? Okay, so it was y is equal to 5x minus x squared. You put 5x minus x squared. So
So
yeah,
x,
yeah. And what limits you're gonna put?
0 and 4.
Yeah. And to find the shaded area, how you gonna do that?
The shaded area, you you minus the area from the first one from to the second one.
Yeah. That's what we had to do. Mm-hmm. Go to our new page real quick. I think this deserves a whole page. So Amy, you got through with the question?
Yeah.
All right. You did everything I did, right?
Yeah.
All right.
Mhm.
Awesome. So the first step is to solve simultaneously to figure out the intervals that define where you're working with, right? Um, since you have two graphs, that means you could find the area of two things and we looking at how they interacting with each other. That's what we're doing, right?
I'm coming back just now, right?
Okay. All right. So Amy, is something working?
Yeah.
All right. I'll check it. All right. So there's a really simple way to summarize everything I just said. So in other words, um, if I want to find the area of the shaded region, most of the time you just have to use this formula. So area of shaded region, typically this is the way how to do. Is the formula. Yeah, that's it. Excellent job, Amy. Excellent job. That's correct.
Okay. I'm very happy.
Yeah, it should be. That's very impressive. Let's do this in law six. I just want to stress the layout a little bit. I mean, this could come, man. I don't know. Sometimes CXCs we cannot crack, and they can bring this. I don't think it's anything too hard. I really don't think it's anything outside all their capabilities. It's not like it's pure maths or anything. Well, technically, all of this is pure maths, but just like easy pure maths. But this is not anything new, right? And this is just compiling everything we learn. Like if you had to say, is this anything new? Like, is this something you could possibly figure out if you didn't learn it in class?
Yeah. Mm-hmm.
Cool. So again, the steps are you solve simultaneously, and then you do this. This is step two. But this formula will always work depending on the kind of question I have. You need to look at it yourself and see where you're subtracting. I showed you all the process. So you have two graphs. That means you could find the area of one graph, the other graph, and you can figure out what you're going to do with the two graphs. Right? Yeah. So that's that. All right. So that being said, Aliyah, are you back?
Yeah.
All right. So Aliyah, I gave you a formula. You don't have to do all this in the exam. You just have to do this formula. So all you have to do is you're gonna integrate for the upper graph. And what B and A is, B and A, those are the intervals you found by doing simultaneous equations. That's like the lower limit and the upper limit.
Mm-hmm.
So the upper graph, so in this case, what was the upper graph? What was the graph above? What was the upper graph? Aliyah, what was the
Um,
upper graph?
the upper graph,
Upper graph just means like the graph on top,
y is equal to 5x minus x.
right? And the lower graph was
Y is,
y
y
is
is
equal,
equal to x.
right? So that's the basic formula. You're gonna integrate the upper graph to find area that's, and you're gonna minus it from the area of the lower graph. That's it. So that being said, I'll give all you a question on homework, a question for homework, testing this. So let me send the question now, right? I'll send the question now. And if you're having trouble with the question, just message Amy. Amy can show you the question. Right. So yeah, guys, thanks for coming to class today. Apologize about starting class late, right? I honestly didn't think I'd wake up so late. But anyways, Ali, I have any questions?
No.
Amy, what about you? Like, you need to clear up anything?
No, I understand.
All right. So Amy, your job is to revise, go through like your notes, check out all the formulas, make sure you know how to use all the formulas, and try the advanced test.
Yeah.
Yeah, right. And you could try 2024 hard maths as well.
Okay.
So yeah, have a blessed day, everybody. Later.
Bye.
Goodbye.